Thank you very much for attending this reading.
Sing. My name is Baptiste and I'm from the FreeBSD project. Yeah, we often meet together to share our thoughts and vision about what's going to be the next big thing in IT, or have a long philosophical discussion about technology in general. That's how we predicted that the cloud would be a thing before the word was even invented.
Still being useful before it's still being useful.
Absolutely. Anyway, I think it was around 5 p.m. Beautiful afternoon. Yeah, okay. Who are we kidding there? Yeah, it was more something like 2 in the morning.
Yeah, we're probably into some random bar, having our 10th glass of red Californian infant.
No, Burgundy. We're in France. You can say you're drinking that thing.
Yeah, sorry. So Burgundy. It was Burgundy. So I started complaining that the Burgundy did not taste it.
Oh, so if no taste, again, we're in France. We were having a Burgundy, a Californian one in that case.
Whatever. So, as I was saying, the wine didn't have any flavor anymore. And that's when it hit me. Oh my God! This is acting like FreeBSD. You guys suck. You guys don't have flavor. Okay, so what is flavor? Flavor is a very interesting concept. I'm not aware of any other package manager in Unix land that implements the same functionality. Basically, it allows providing packages compiled with a different set of options. So that's obviously very convenient from a dependency point of view, since according to the option that you set for the compilation, the final binary will change as you might end up linking to different libraries, obviously. So since you want to be in control, but providing packages compiled with a good set of options is quite complex, while sometimes it's next to impossible to have a good default, because it's a hard compromise, and that's where the flavor kicks in. For example, you can install SAML with or without SASL support, or with or without LDAP support, etc. It's completely different from what we call sub-packages, which are just split packages. These are typically used when you have a software that comes with a huge amount of data, for example, like audio or graphics or games packages. And these rarely change, while the main binary does change each time it is updated. So instead of having a huge packet that bundles a complete set, you just update one small sub-package. It can also be used for things that ships modules or add components that have a lot of different dependencies. PHP is a good example of that. On OpenBSD, for example, we compile it with pretty much all the possible options. So the build requirements are big, but the port only needs to be built once, and since the package itself is then split into several sub-packages, you only get to install what you really need, like PHP IMAP or PHP MySQL, etc.
With that last one, you really took the wrong example. On FreeBSD, we have fine-grained split package for PHP. So if you want PHP with IMAP, you just install PHP 5-IMAP.
Yeah, but my point is that actually sub-packages allows you not to have to deal with fine-grained packages. If I understand correctly how your port tree works, you still need to build each PHP modules one by one, while you do everything at once.
Yeah, you're correct there. There are not really sub-packages, and it would be nicer if we had them. If you're speaking about flavors, a good example would be probably OpenLDAP client compiled with or without SASL support.
Right, so if I need SASL support in OpenLDAP on FreeBSD, I assume that I need to build it myself, right?
Yeah.
Okay, that's fine. But my fear is what will happen when I suddenly run package update and package upgrade?
Yeah, probably bad things, like removing half of your packages.
Nice.
So, yes, it's true that we do not have the flavors nor sub-packages, but there are a lot of ongoing works. Actually, flavors should be committed in the next hours, days. We talked about it yesterday. So the thing is, that work is pretty hard as it breaks the design of the way some tools that are heavily used by some user works. For example, port master and port upgrade. And those tools are right now barely maintained. So as soon as we make such modification, we have no one to update those. So on FreeBSD in general, we try how to have an upgrade path for users to try to avoid breaking things. Keep in mind that we do not release a package set, but the port tree is a rolling release, not tied to a given release, so such change will need to be smooth when it arrives. Which reminds me, you guys do not support upgrading packages on a given release, do you?
Actually, we do support upgrading packaging on a given release. What we do not provide are the actual binary packages.
Yeah.
Yeah, okay, it's true that you need some kind of a build box or something where you can distribute packages update from. But there is work in progress in this area, and we should be able, hopefully, to be able to provide updated binary packages in the next year or so, famous last words. So we just need to agree on the workflow, the team responsible for it, and get the required infrastructure, etc. It's not a technical problem, it's not more of a workflow problem. But talking about package app, it's important to note that on OpenBSD, a lot of operations are done as completely different and privileged users. So you have different users for fetching, extracting, installing, checking the signatures, etc. We, for example, don't really want to go on the internet as root or anything. While I think you guys still do not drop privileges when using libfetch with a package. Can you comment about that?
Actually, that's not true. Package uses Capsicum to sandbox everywhere it is possible to make a sandbox, since Capsicum exists basically. And package also uses unprivileged user to fetch package, or in every areas where we don't need root privileges. So while sandboxing support is there for a long time, unprivileged user mechanism has been added quite recently, but I actually got it in before you did, from a few days.
Yeah. But the libfetch commit was reverted.
Yeah.
So, anyway, back to our topic. We've also tried very hard to provide proper upgrade path for our users, obviously. But the difference is that we don't have to deal with a legacy or a maintain package wrapper that you guys have, like a port master, port upgrade, port super glue, whatever. Our package tools are designed to provide everything one needs for package management without the need of any external helpers. So don't forget, we have a very long tradition of providing proper binary packages over pushing people to actually compile them.
Well, that's also true for FreeBSD now. It's been a while now that we are building binary packages. Most of the tools you're speaking about are mostly to use the port tree directly on the live system rather than using the binary package, which I think is a usage which is not supported by OpenBSD.
No.
Now FreeBSD has first-class citizen on binary packages.
It's perfectly supported by OpenBSD. We just don't encourage people to do it because for 99.99% of the time, it's just not needed.
Yeah. One of the things about the FreeBSD port tree you need to keep in mind is that it works on all supported version of FreeBSD, which, yes, it reminds me that you only support one version of OpenBSD and only for 6 months. Well,
you are correct that for packages, we only support the current release, which at this time is 6.1. The operating system, base system itself, is supported for 2 releases. And aside from current snapshots, our port tree is also tagged to a specific release. That's a design decision. We don't want to enforce to our user to upgrade to a new major version of a particular software. And we don't want to maintain like 4 different versions of the same software to prevent that. So, which is why our port tree does not follow a rolling release model, except for current, obviously. So, but considering the fact that we have regular releases every 6 months, I mean, our packages don't have the time to get too old anyway. Regarding the support policy itself, it's pretty basic. Basically, we support base system for the current release and the previous one. The package is only the current one. As I said, there's ongoing discussion to maybe improve that part. So that's true, that this means that you need to upgrade at least once a year if you want to run a supported OpenBSD release. I don't think that's a bad thing. I'd rather upgrade often in small steps than once every 5 years having to deal and handle multiple invasive changes at once. I do understand the need for LTS-like releases. I just don't like it when I'm the one responsible for upgrading them. So that's it. Well, it can be good to have some long-term support. What the fuck is your policy? I mean, extended support versus normal support. I mean, how come FreeBSD 10.0 was still supported while 10.2 wasn't? I mean, this is all very confusing and makes no sense. And no support can be good if you don't understand how it works.
Come on, that's easy. I will read it for you so that you understand. So, we have the normal releases. Those are releases which are published from a stable branch, were supported by security officer for a minimum of 12 months after the release, and for a sufficient amount of time, if needed, to ensure that a newer release for at least is out for at least 3 months before the older normal release expires. And then you get the extended one. So, selected release, normally every second release plus the last one from each stable branch were supported by security officer for a minimum of 24 months after the release, and for sufficient additional time, if needed, to ensure that there is a newer extended release for the last 3 months before the older extended release expires. It's easy, no? Yeah, no, okay. I agree. It's a mess. Well, actually, I should say it was a mess. Furthermore, it was causing a lot of issues when maintaining the port 3, as we had to wait for at least 2 years with this model to be able to use some modern tools in the port 3, so it was kind of a pain. Well, we changed that with FreeBSD 11.0, so now the model is way easier to understand. So each major version of a stable branch is explicitly supported for 5 years. And then we can issue a new dot release whenever we want without extending that date. When we issue one, the previous one is maintained for only 3 months, so you have 3 months to upgrade. So going from 11.1 to 11.2 and then 11.3. So that way we can benefit, the users can benefit stability for 5 years, and at the same time they have the new features.
Oh, you're finished, sorry.
Yeah.
Okay, well, it looks like FreeBSD support model keeps newer features out of the hands of users because it can be years before they actually see the new features in the release, right? For me, it reduces real-world testing and, well, basically benefits no one. In my opinion, OpenBSD model is super easy to understand and keeps the code stable but still pretty fresh. Whatever is in current at a certain period of time will end up in the release, which would take at the very worst 6 months.
So you seem to have misunderstood one of the benefits of the new release model. New feature, as soon as they are not breaking binary compatibility or things like that, are merged to the stable branch. So as soon as we need a new feature, we'll just issue a new release and your problem is solved. So you get new release supporting those new features anyway.
Well, you did say that you had to wait for at least 2 years before being able to use the modern tool available
with the previous model.
Oh, previous one. Okay. Well, anyway, we do things differently. We're not afraid of breaking binary compatibility in current and for our upcoming release, obviously. So we don't do stuff like merge of backport usually. But as you put it, your process is kind of a mess. So yes, I may have misunderstood. So,
given we do support binary upgrade, it's very easy on FreeBSD to upgrade from a minor version to another minor version. By the way, binary upgrades also works very nicely across major releases on FreeBSD. But hey, I must be losing you somewhere here because it's true you do not support binary upgrades, neither for security fixes or across releases. Seriously, it should be very tedious to maintain some OpenBSD boxes in production.
Yeah, I see where you're going here. The way you put it is not not entirely true. Binary upgrades between releases are and have always been perfectly supported. What is not supported are in-place upgrades of the base system from one release to the other. But is that really an issue? Supporting in-place major upgrade would not prevent us from having to reboot anyway. So, for me, I think the upgrade process of OpenBSD is just one of the easiest and fastest I've ever encountered. Just reboot on the new release, boot on the BSD run this kernel, and it will do the rest for you in like 5 minutes. And also, thanks to our auto-install and auto-upgrade functionality, you can give it the path to an answer file via DHCP, and you won't even need manual interaction. You can also upgrade your packages to match the new release, and add this to the fact that sysmerge, the current configuration files merger, is automatically run on boot. Well, you're pretty much left with nothing to do manually.
Yeah, well, sounds okay-ish, but what happens if you have to upgrade for security patches?
Until a few months ago, updates within a particular release were only provided in the form of CVS patches. This has changed since the 6.1 release, and the new syspatch utility, which is a base system update tool that will basically fetch, verify, and apply binary updates on the base system. It tries to design a bit what our installer does, so it's very simple, secure, fast, and pretty much fluid.
Well, on the FreeBSD side, we do support, as I said earlier, in-place binary upgrade via the FreeBSD update tool. So the basic design behind FreeBSD update is that we create binary diffs and we binary patch the system with the changes. So it is very convenient to receive security fixes and very fast for that. FreeBSD update also allows you to upgrade from one major version to one major release to another major release in place. And the procedure is basically what happened under the hood. First, it installs a new kernel, then it reboots on the new kernel, then it installs the user and match configuration files and remove the files that are not needed anymore in the new release. And that works. It works fairly nicely for a while now, but fetching all the binary patches when you're upgrading from a major release to another major release can be very, very long. Another issue is that producing the packages is not really trivial for FreeBSD update, as it needs reproducible builds to be effective. That's why we're now looking forward to be able to provide a new mechanism based on package itself. To be honest, there is also drawbacks about in-place upgrades when we need to maintain strong backward compatibility on some kernel interface versus the rated userland tools that goes with. A particular case is ZFS. It's an interesting thing to look at. So LMS consider the version in the kernel goes with the version in the userland, which is nice. So if they modify the kernel interface, they modify the userland tool that goes with, and everything is fine. But on FreeBSD, because you reboot on the new kernel first, then you might end up with userland tools that are not compatible anymore with the kernel you're putting in. So when we are receiving the patches to update ZFS and there is an incompatibility introduced, then we need to make the compatibility scheme ourselves. So.
Okay. Yeah, that sounds quite complex. I mean, in-place upgrades can be interesting when the upgrade itself takes a while, for example. In theory, it would prevent long downtime, but in reality, production should be resilient and services should be redundant, so it's not generally such of a problem. Also, the release upgrade process on OpenBSD is literally the fastest one I've ever used. If in-place upgrade actually meant reloading, updating and reloading both the userland and the kernel without having to reboot them, I'm sure it would have my vote.
So that said, about the upgrade path, an interesting policy that we have on FreeBSD is POLAR, principle of least astonishment. It's a very strong policy on the FreeBSD saying that we should try very, very hard to make upgrades as seamless as possible and avoid breaking end-user boxes as much as possible.
Well, in general, we're not really afraid of breaking backward compatibility when we think it makes sense, of course, and help push our ideas forward. That said, I can understand the need for a POLA sometimes, but not when it goes against basic security practice. For example, just to satisfy third-party clients, you guys kept TSA encryption, AES CBC, Cipher, and SSH1 support in your OpenSSH. For a long time after upstream, which is us, dropped it. That's the kind of compromise that we're not willing to make.
Well, that's not entirely true. POLA does not prevent me from making those changes, but if they are done, they should be driven in a manner so that the user are warned long before. This is particularly true on a given branch. We usually make big changes between a new major release. On newer branch, they're just then removed.
Well, then, let me read this. According to FreeBSD SVN revision 303716, dated August 3rd, 2016, remove DSA from default cipher list and disable SSH1. Upstream did this a long time ago, but we get DSA and SSH1 in FreeBSD for reasons which boils down to POLA. So that was a good time to catch up.
Anyway, speaking about delivering binary upgrades, you guys must have a very hard time building the thing, considering you're still using the giant lock almost everywhere, meaning you cannot use efficiently multiple cores.
Well, for regular desktop-like usage, our big lock SMP implementation model, the kernel lock, is good enough. The reason is that most of the time on the workstation, you only have a handful amount of cores, like between 2 and 8, and only one socket. So our actual scheduler isn't bad. It's just that it's a bit old, to say the least, and was written for real SMP machines, meaning that it does not consider things like, for example, the cache distance between cores, and that's the main reason why machines with several sockets often have a lower performance than the ones with only one socket. There's less ping-pong involved. So we can also use 24 cores, but in the context of huge bulk building, for example, we have a much better performance concatenating the works of 6 by 4 cores machine for the time being. That's true.
Well, how the change can be done in the OpenBSD model? I mean, on FreeBSD, it took a lot of time to get most of the architectural work done so that we can have a proper SMP, and it also led us to some of our very good releases like FreeBSD 5. I'm not saying that the road we took is the one true way, but I can't see how this can be achieved in an incremental way that is yours.
A few things can be incremental because they're not directly related to the scheduler itself. Several scheduling-related issues that we had on OpenBSD came in fact from a spin locking in librthread or a POSIX pthread implementation. But that has drastically improved since we implemented Futex and make our pthread library use it. And in contrary to the myth, OpenBSD scales very nicely on big user and workload. Now, is raw performance on par with FreeBSD? Probably not, but our priorities are different, and we're okay losing a bit in this area if it gains us more security and simplicity. Actually, I would go even further than that. I would say that we'd rather crash and panic if we detect an unsafe behavior.
Well, to be honest, SMP is something that is always evolving. Right now, our next challenge on FreeBSD side are to have better number support, to improve the overall locking systems by using lockless mechanism where possible, by using, for example, concurrency kits. What is the current status on that on OpenBSD?
Well, our entire SCSI stack and kernel profiling are already fully SMP, for example. And recently there's been some huge progress on making our network stack more SMP friendly. The goal of the network being able to use multiple threads to forward traffic, for example. I don't think you will argue that modern scaling is hard. Most operating systems had to do it and redo it again multiple times. We are learning from others' OS experience, and as usual with OpenBSD, we're trying to implement something that is simple and will match the project goals. So as you say, it wasn't an easy road for you. So that explains why sometimes we may seem a bit behind in certain aspects. We take our time to do it according to our standards, or we just don't do it.
So, while you're here, maybe you can explain me something in OpenBSD I do not understand. You seem to keep writing again and again your own tools when there are already BSD licensed counterparts. I mean, HTTPD, SMTPD, VMM, etc. Aren't you suffering some kind of NIH syndrome?
Well, that's actually a very good question. I'm glad you asked because there's actually, in my opinion, very objective reason to do that. The first one would be trust. We have a coding style, obviously, practice and process that makes us confident in what we develop. Another reason is also control. We know someone will not decide to change the software license one day to the next, or start adding nodes for each and every crazy corner case that's out there that only 2 people would use, for example. So I'm looking at how many CVEs impacted NTPD or OpenSSL in the last couple of years. It should be a good hint as to why OpenNTPD was created and why LibreSSL was forked from OpenSSL. So if I'm not mistaken, for example, a lot of your security advisory have been related to the NTP daemon, including the base system, the so-called reference implementation. So I don't think it's really having an NIH syndrome wanting to write secure implementation of these tools.
Right. For the example you took, okay, I can understand it. But I mean, when you have already some BSD quality alternatives, you're still doing it. What about Beehive? It was working. It could be easily, it could easily fit the security requirements about security and sandboxing. So why yet another implementation?
Well, there's been an initial porting trial a few years ago by Mike Larkin, but compiling a single file ended up being a huge amount of work, so let alone run. And when you're confronted with such code, you really need to ask yourself whether it's not worth just creating something from scratch instead of porting something that is not portable. The situation, I agree, may have changed since now OS X have an implementation with the Xhive, but that was one of the reasons that VNM was created. I would also add that it helps us providing the base system that we want. I mean, the base system that for us just works, without having to depend on the choice done by the external projects.
Right, but another example I could have is Capsicum. You decided to make your own sandboxing mechanism instead of porting that one.
Oh, but there is a very good reason for that, actually. But since you brought up the subject of security, let's talk about that, and we'll compare sandbox implementation later on. So, as some of you know, most daemons run with privilege separation on OpenBSD. That is, most of the code is run rooted as a non-privileged user. OpenSSH led the way on this topic years ago. They also use privilege revocation for dropping privileges as soon as possible. A good and simple example to look at is NTPD again. It's a very standard OpenBSD daemon, so it's written with principle of least privilege in mind. And so not only does PrivSet and PrivDrop, but in addition to this, it has a completely privileged separated TLS speaker for the constraint feature with no memory sharing or FD passing and with a very limited amount of allowed system calls thanks to Pledge, which I will describe later on. The constraint feature that I talked about of NTPD basically queries the time from a trusted web server over HTTPS, reducing the risk of a man-in-the-middle attack by comparing that time with the one that the remote NTP server gave us.
So for NTP, well, you're right, but there is one price behind that. You have a half-baked implementation. You have an implementation that cannot authenticate the peer you're receiving the time from, and this could be a huge problem. And you're not using the standardized mechanism in that case. You miss half of the feature NTP is supposed to provide. And yes, I agree on the fact that most people won't care about some of those. That said, I would love that we get something else than NTPD in the base system, but an OpenNTP is probably too light.
But you're actually describing exactly OpenNTP's price. I mean, it actually does not need to authenticate thanks to constraints. And it does not need to implement the kitchen sink because no one cares. And if one does, then one can install the reference implementation. I mean, it's not always about math and algorithm. And sometimes good enough really means good enough. Anyway, on a related topic, OpenBSD is also well known for its numerous exploit mitigation techniques. It's important to note that all of these have been enabled by default for some of them for years and are very hard or even impossible to disable. So just let me give you a few examples. Like we have ASLR to obviously prevent buffer overflow attacks. We have a WXOX, memory page that can be either writable or executable in both the kernel and the user land. We have Propolis, the stack mashing protection using bounds, checking, and canary. We have Pi, position independent executable, also for static binaries. To the executable, like a random address, which stops stuff like return to libc type attacks. Since not too long ago, we have CAR, the kernel address randomized link, which will generate a unique kernel on each boot with random internal structures, preventing leaking internal kernel functions, pointers, or objects. And we also just got TrapSlet to limit the availability of attacker to exploit return-oriented programming like that by jumping randomly in programs. So obviously, each of those techniques could round their own talk, so I won't go into details into them. But I want to insist on the fact that the way we approach security is that we always assume to be running in a hostile environment. We also refuse to implement dangerous functions like word exp. I mean, libc, spawning a shell to perform word expansions. It's like, this is completely crazy.
True. We also provide some Propolis mechanism. About ISLR, we have an implementation which is in review right now, opening some VM people to be able to review it. On our side, we have the MAC framework, which is a very interesting framework. It's mandatory access control. It allows to restrict many things. So with MAC, you can restrict user access to system resources, including not seeing sockets opened by other users or many other stuff. You can also have a firewall-like policy on file system to be way stricter than the regular file system rights. You can restrict network interface accesses. You can limit the scope of the process one can see, compartmentalizing them into partition, and way more things. Another interesting feature that we have is OpenBSM. It's a very full-feature audit system which you can use to monitor everything that happens on the system, and you can distribute the log over a central server. It also supports the Linux version of the protocol for the centralization.
Well, see, all this technology you mentioned are, for me, very interesting in theory. I do agree. But in real life, I almost never see them in action because they're too complex to use and next to impossible to audit.
Well, let's go on the sandbox part. Capsicum is a very nice sandboxing mechanism that we have on FreeBSD. It leverages the concept of capabilities. What is very nice about it is once you're inside the sandbox, there is absolutely no way you can exit it. Even child process inherits capabilities. So that's by design. It is really designed for developers to secure their own application by strictly restricting the capability of an application to only what it really needs to be able to, and strictly what it is really needs to be able to do. We have started converting most of the base system to use it. We're not really there yet because, yes, the design of Capsicum allows no compromise, so it's not always that easy to convert existing software to Capsicum.
Yeah, that's where I wanted to go, actually. It seems that Capsicum, it's too complicated, and that's why it doesn't get much used by default. The pledge disco is actually a very good summary of what OpenBSD project is about. Develop practical and affordable security, meaning simple and easy to implement and hence enabled by default almost everywhere in the system. I mean, 30% of the base system was pledged after only 2 months. Today it's more like 85 to 90%. I don't have the exact number, but and even some monster ports like Chromium are pledged. So anyway. talking about Pledge itself, for us, it's designed to serve two goals, basically. Encourage refactoring towards safer models and reduce code exposure to the kernel. So people often compare it to a seccomp BPF on Linux, although Pledge is not a system code firewall, but rather somewhat like a facility to explicitly allow a group of system code in the form of promises with some sort of pre-declared profiles like INET, shown, DNS, TTY. And obviously a pledge process is forced into a restrictive service operating mode where abilities can be reduced but never regained. And if a restricted operation is attempted, then the process is killed with an uncatchable seed abort. In theory, I agree that capability-based security may be more advanced, and it probably is, but what good is a feature if it's too complex to be widely implemented?
Another security feature that we do have on FreeBSD, and we have it for a while, is gel. It allows to create prison container. We have it on FreeBSD since FreeBSD 4, I guess, if I remember correctly. It's very simple and easy to use. Almost everything can be disabled and is disabled by default, or can be restricted inside the gel. So you can restrict network, file system access, CPU, memory, routing tables, and nowadays it can even be nested. You can have their own DataFS dataset dedicated, or have virtual network.
Well, in that regard, I do agree that we suck. OpenBSD has no container-like technology. There's been an initial effort years ago called sysgel, but it was abandoned because of an inherent design issue in sysstrings on which the tool was based, and that would basically allow fading gel by exploiting a race condition. But anyway, getting tired, so I think it's time to move to something else and do a break.
Yeah, let's do that.
Thank you, and see you after the break.